Hi, welcome back. Today we're starting a new radio. This is an RCA Victor from 1940. Model number is 12X2. Has a nice label to it. I got this off of eBay for a fairly decent price. What appears to be missing, or I shouldn't say missing, are the knobs here. These are not the original knobs, and as a matter of fact, let's see if I can pull these off. These are two different knobs that do not belong to this radio, but I have quite a few RCA radios, and I should not have a problem finding a replacement for these. I'll just put them in my container. Also, I noticed I turned this over, this screw came out of the back. So it's probably ready to be taken off. There we go. So let's look at the cabinet a little more. No cracks. Paint is pretty bad. This handle doesn't appear to be working. When I look inside, I can see it's because it's missing a spring on this side. So I'd be replacing those. If you notice something a little different on the band, I don't know if this comes up well on the video, yes it does, you see it says police. Most of the other radios don't go that high in the band. It doesn't really matter in this case because I don't think, especially around me, that they use AM broadcasting anymore. So that's just a feature of the older radios. So the case will be stripped. Oh, I see, you want to make sure this is not a crack. There actually is a little hairline crack. Let's see if you can pick that up here. You can see it on the outside better. It's a little hairline crack, and it's starting to come through to the back, so I'll definitely have to glue that up. Generally what happens with these radios, and this is an old one, as I said, from 1940, it's very, very heavy, the chassis. And if you're picking things up here, the weight of the chassis pushes on the Bakelite here, and happens enough times, it starts to crack. So alright, the radio is filthy. Absolutely filthy. 5 tube. It looks like the normal supply of tubes. So we'll just quickly go through them. And I'll take them out as we go through. 12 SQ7. This should be the 50 L6 GT. On the right here, this should be the rectifier, which would be the 35Z5. Yes, 35Z5. Then we should have the 12 SA7, which is right. And then this should finally be the 12 SK7, which it is. Now before I make a determination if I'm going to actually work on a radio and restore it, I want to check a couple of things first, because some parts are harder to find and some are harder to replace. So what I usually do is I go through with a multimeter and verify that there are no open coils and things like that. I check the volume control. I check the speaker. I check the speaker coil. I check the antenna coil. I check the two transformers up here. And I also check the oscillator coil over here. So I'm going to be setting that up, and I'll show you what I do to check each one of those. Welcome back. As I showed in my first video, I'm always going to put my finger through the speaker on accident, so I'm going to cover it. This actually has a little tear in it right here, but that's easily replaceable. The rest of the speaker seems in good shape. I'm going to take my 5-inch cover and just tape it up. And then we'll go through what we want to do to verify that everything is still worth restoration. Okay, that will hold for now. I will be right back. I am back. I was able to download 2 service manuals from the internet for this particular radio. If you look at this one, this is the service manual from RCA Victor. It's about 6 or 7 pages, and they actually had this model has the same configuration and setup for 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10 items. I have the 12X2, which is listed right here. And if you look down here, it shows you all the chassis for each one. And according to this, the 12X2 should have RC1001B. Unless we can check that, because if you look on that chassis right there, you can see RC101B. So that's the right one. Now what I did notice is the schematic here is showing you the schematic for a different chassis. So most of the items will be the same, but not all of them. I was actually able to download a rider's manual and print out a nice big piece of paper here. And if we look, we can see this has the right chassis. Right, 12X2 is the model, chassis 100C. Actually, this says 100C. 12X2, radio chassis 1001B. So this will be the right one to use. Although I will need this particular item, because as I go through these different pages, it does give the parts list and the differences between the speakers, between the oscillators, and different parts for each model and each chassis. So it's well worth having as much documentation as you can. Alright, let me set up my multimeter and we'll get started shortly. Welcome back. I have this now set up with my multimeter, and I'm checking the speaker. As you can see right now, it's set for 0. At least I can tell. I have items on my screen that I can't see that are overwritten. But basically you hook up the meter to the back here, turn the switch on, and the hope is to see numbers coming up here, and there we go. Good. So we'll see the ohms and the resistance, and that's all fine. That's what's expected. Next, I will set it up to check the speaker coil. Okay, looking at the schematic, and I'm looking at the speaker coil here. And we can see that there's 3 wires coming out of it in the schematic, red, black, and blue. You can always depend on that when you're looking at the radio, especially with the cloth-covered wires from this time period. You know, 80-year-old radio, the colors fade, and sometimes it's difficult to tell one color from another. So you should definitely look at the radio directly and determine what the right color is. So if I look here, I can see the red one is going to the output tube 50L6GT, and that's going to pin number 3. And you can see the little key here. I don't think I've ever explained how that is, but if you look at the bottom of a tube, you can see that there's a little key there, right? And then from the bottom you can count 1, 2, 3, 4, 5, 6. There's 8 pins. If you notice, not all of them have pins because some aren't used. So we're looking at pin 3 and pin 4 in this case. And then we're also going to look at pin 3 and coming down to the output of the electrolytic capacitor down here. So let's take a look at that. I already have it set up for pin 3. The multimeter, you can see there's a value there. So let me go to pin 4. Good, and we definitely have continuity there, so that's fine. And now I'm going to go all the way over to the output of the electrolytic capacitor, which will be replaced. And he's going over to here. And he has a value as well. So at this point it looks like the speaker coil will work properly. Now we're going to check the first IF transformer. That's what I've highlighted in the yellow here. So we should be getting around 7 amps to make sure we have the proper continuity. It doesn't have to be an exact number. As long as it's not open, we're pretty sure we're going to be fine. So to do that, we're getting the one side, which is here, the blue and the red wire, and that's going to 12SA7, which is the detector and oscillator tube. And on the other side of the coil, it's going to the IF amplification, 12SK7, and that's going to pin 4, and also down to the ground, not to the ground, sorry, to eventually to the ground, but to the negative black wire. So I will show you how we can do that. A little close here, let me back it out a little. So the first thing we're going to do is check on the left side, which is a 12SA7, and we said pins 3 and 4. There's pin 3. I'm using these clips because they're easier to get my hands out of the way so you can see the readings. And then pin 4, and this says 8.3, it's supposed to be 7, that's close enough in this case. So that side of the coil is fine. And now for the other side, if I can get this out, good. For the other side, it's going to go into 12SK7 pin 4, which is over here. And you can also tell by the wires coming out, you can always trace it that way too. In this case, the green wire is pretty good. It's a rubber wire, not a cloth wire, so it doesn't lose the color, although the rubber does tend to flake over time. And it comes out from the black wire, which comes down through here, and if I trace that all the way over, I can see that's going right to here, and that's 9.2 as well, so this particular tube is fine. Okay, I'm going to set up for the second IF transformer next. Thank you. Okay, so now we're checking the second IF transformer, which is over here. On what we're expecting to get about 16 ohms from each side. I will show you how I measure that in a moment. The one thing I wanted to point out, that for the bottom piece coming out here, normally I check against this pin, which I will do, but it probably won't be 16 because there's a capacitor in the middle. Anytime there's capacitors or resistors sitting on those points of contact, you're not going to get the exact reading. But in this case, we're just looking to make sure that we're getting something. So that's what's important. So the first one, we're going to the 12SQ7 tube. And, sorry, 12SK7 tube, which is the one in the middle, and we're looking at pins 3, and, I'm sorry, I'm trying to read my own schematic here, 6 and 8 it looks like it would be. A little tight in here. Maybe we'll just hold them down and they can see. 6 and 8. I'm expecting, let me get that better on the camera. Sorry, I'm back. Somebody came downstairs. And actually I can move this out a little less. I hooked it up to pin 6 and 8 as I mentioned. We're expecting 16, and here we have 17. So now we're going to check the other side, which goes to pins 3 and 4 of the detector tube, 12SQ7. Now here's where I anticipate we're going to get continuity, but not the ones we're expecting. One, 2, 3, and 4. And yes, we have something, but as I mentioned, it's a higher number because of what that was. Because of in this case, this capacitor and a resistor being connected in that string. Good. Next thing we're going to check is the oscillator coil, so let me get that set up. I'll be right back. Okay, now we're going to check the oscillator coil, which is down over here. They give a little diagram of what each thing goes to. We're checking 7 and 8, which we're expecting 7.5 ohms. I have it set up already, and you can see 7.2, so we're good there. The final thing I'm going to check is the antenna coil, and there's really nothing to show you except to make sure we're getting continuity. I'm going to collect those, and I can see, yes, I'm getting some, so we know the antenna coil is fine. So at this point, you know the radio. Once we do a recap and check the resistors, there's a 90% chance this will work as it is. I actually kind of checked this ahead of time, and based upon just checking to make sure there's not a known short in it, we'd be able to tell right away if there's a problem. So you can see, of course, I have the power off. I should mention everything I'm doing now is a test with the power off. Obviously it's not plugged in. You don't want to do tests with the power on unless you're checking for voltage. So I'm just going to turn the radio on here, and you can see the numbers moving, although the fact that it's not staying and it's jumping around, it means it's probably electrolytic converter or some of the capacitors. Sorry, the electrolytic capacitor or the other capacitors are not behaving well, and we're replacing those anyway. All right. I will move on to the next step.